So we're going to look at the application of development methodologies, or how do we actually go about building software. And we're going to look at implementation methodologies, how we can use computer-aided software engineering tools, and some of the current trends in employment and the IT market in general. But first, let's start with development methodologies. So when we come around to deciding what approach we're going to take to building software, there are a large number of things we have to sort of take into consideration. The scope of the project is probably the most obvious. Just how big is it? If you're building a tiny little application that you're going to use yourself, you're going to use end user. If you're building a massive, great big application that's going to be used by an international corporate, you're most likely going to use a structured approach. So the scope of it's probably one of the most important things to take into consideration. The type of project, if it's a website, it's going to be one way. If it's a database application with a desktop app that goes along with it, it's going to be completely different again. You may also be limited by the skills that you have available in your workforce. So not every application that you want to build, every single project you want to build is actually going to be achievable by who you have available to you. And also, you may not actually be given all the requirements that you might need. A client might have a fairly vague idea about what they want to build, and that's going to change the way that you approach building it. As with all things, budget, the amount of money you have available is going to have a significant impact on how you actually approach it as well. And let's be honest, fashion applies to the development of software as in anything else, and there are lots of different trends and the new hotness in programming languages that will largely dictate how you approach solving a problem. So in the NESA software design course, there are 5 methodologies that we look at. We look at the structured development approach, which is the set stages of development, the corporate model of software development, the large projects, the cube farms, the programmers, busily typing away, and also a lot of documentation, planning, and everything else. We'll look at prototyping. So how do we test ideas? How do we build working models of what might be the final product? Agile is probably the new hotness. It was the new hotness 10 years ago. It is now rapidly falling out of favor as its ideologies has largely been ignored and it's been used more as a tool for management. We'll look at rapid application development, or RAD, fast, short, cheap development, and then end user, which is what's used when you want to build something for yourself. First of all, let's look at structured development though. So the structured approach is characterized by a large budget. This is because it requires a large, highly specialized workforce. You're going to have people who are database engineers, networking engineers, graphical user interface designers, user experience designers, project managers, systems analysts, all of these people who are highly specialized, highly educated, with a lot of experience, a lot of income. So the largest part of any software project that's done in this is largely going to be the actual paychecks that go to the developers who are doing this. And also because of the nature of the project, it takes a long time to develop. Why does it take so long when you've got so many people working on it? Well, there's a focus on quality, security, and uptime. Uptime being, just how reliable is it for us to use. And so as such, it is really only suitable for large and complicated projects. If you're trying to build a small little application, well, that would be overkill. Think ATM, a banking system, accounting systems, hospital check-in and patient management systems. Those are probably going to be more sort of focused towards the structured approach. One of the key elements of the structured approach is that it's broken into 5 key stages. And we start with defining the problem. So during this stage, we have to really identify what it is that we're trying to fix. What is the problem we're trying to solve? And the best way to do this is to interview people, question the users, find out what needs to be done. What's the actual requirements that are going to be needed? But when you're dealing with users who will largely say, well, I just want it to be faster. Well, where are the choke points of the application? It just needs to be better. Well, what's bad about it now? I just wish it could do this vague, obscure thing. So you will need to spend a lot of time, or the systems analyst will spend a lot of time working on what the actual requirements are. What is the actual hard, quantifiable, this must be the case that needs to be built? And just as importantly, establishing boundaries. Feature creep is the biggest bane of any large project. Is when the users gets excited about the first edition of the project or the first draft they see, and they go, "Oh, wouldn't it be great if we could also do this, 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 and this?" Well, you haven't budgeted for that. You haven't planned for that. So it's very important to establish boundaries. This is the most important stage in the development process. If you make a mistake here, it will affect every other part of the development process. It is the easiest place to fix things. If we don't fix them here, it's the same as choosing the wrong compass direction and going on a 1,000-kilometer journey. The amount of distance that you'll be away from your target will be exponential the further you go down. So it's very important that this stage is taken seriously, that it is very, very detailed, that it is well thought out, well planned, that you know what it is that you're actually trying to do. After we've defined what the problem is, we need to plan how we're going to fix it. So during planning of the solution, we will make some fairly serious decisions about what technology we're going to use, what are the data structures going to look like, what database engine are we going to use, what kind of user interface we're going to have. We're going to think about the algorithms that we're going to use. So we're going to try and solve some of the problems on paper first. So we can try and identify what some of the problems might be before we actually get to the building phase. We're going to look at the models. We're going to build Gantt charts to schedule it. We're going to look at input, process, and output charts, storyboards of how the user is going to interact with the application, flow charts that help us understand the logic of the application, data flow diagrams help us understand how data moves through the system and how it's processed and manipulated and changed. All of these things happen during planning the solution, so that by the time we get to implementing the solution or building the solution, we really know what it is that we're planning to do. We have a very clear vision of what needs to be done. So when we get to this stage, we can actually be really focused. We can really just hit the nail on the head every single time and make sure that we're really making sure that we're solving the problem. So it's most likely going to be using a highly modular design at this point, because remember, we are working as individuals as part of a large project. That means that when we're building classes, when we're building our section of the code, we're working either in a small team or by ourselves, and then integrating everything back in to the main system. Modularity allows us to do this. You'll find that when this is actually implemented in businesses, there's a lot of logging of your work. I had friends who worked for IBM. When I talked to them about their development day, they would work on code in the morning and spend the afternoon logging what they'd actually coded in the morning. So there's a lot of paperwork that's involved, because that helps make sure that the project is actually on track, that no errors have been introduced, that the problem is actually going to be solved at the end. There's also, I'd like to we have a testing phase later in this. You are still testing during this stage, but it's mostly testing to find bugs, not testing to see whether we've actually solved the problem. The testing phase on its own is mostly focused on actually, has the problem been solved? By now, most bugs should have been dealt with. Okay, so really we're looking, we've defined the problem, we've planned the problem, we've built it, have we actually solved it? Okay, and that's the main focus of this stage. Now, there are two types of testing approaches that can be used, and it depends on what type of program that you're building as to which one of these you're going to use. So you'll either use acceptance testing. So if we've been hired as a company or as a programmer to build an application for somebody, they need to accept the final application that we've built. Okay, and that's acceptance testing. We accept it, we write a check, here you go. If we're building something that's going to be sold commercially, we'll use alpha testing and beta testing. These two different models, we'll talk at these later in the course, but alpha testing is done in the actual development environment itself. Beta testing is done out in the wild in a much more realistic sort of environment. So we've tested the solution. Now we need to maintain it. So the maintenance phase is mostly about introducing new features. It's about making it slightly better. I know if you just used a very vague term here, but let's say we've found that some things are a little bit slow. Say that we've found that the user experience isn't great. Say we've found that there are new features that need to be implemented. This is what's happening in the maintenance phase. Now, the maintenance phase is also highly sophisticated, as is the testing phase, which I did mention before, but I'm just going to add it now. When we decide what we're going to test, we need to define the tests, plan the tests, implement the tests, test that the tests were right, and then maintain the tests. When we come to maintain the solution, we define what needs to be maintained, we plan the maintenance, we implement the maintenance, we test it, and then we maintain what we're planning to maintain. This leads it to being often called the waterfall approach, which we'll look at it in a little bit. So, in sort of summary, features of the structured approach is very large scale and complex. It's very costly, so usually has a large budget. The time taken can be considerable. Think in terms of years, at best, perhaps 6 months. It's usually easily modifiable and maintained after completion because you've spent so much time building it in a modular way with so much documentation. It's expensive because it uses large teams of diversely skilled professionals. Now, that waterfall approach, as you can see, when it's written out, you've got defining, planning, implementing, evaluating, maintaining, and when you get to maintaining, defining, planning, implementing, evaluating, maintaining, etc., etc. So let's look at prototyping next. So the prototyping approach is used to perhaps make an early working version of an application. And we're not necessarily worried about a highly sophisticated final version. We're not worried about bugs necessarily. We're not actually interested in solving a problem as much as actually finding out if this is an appropriate way to solve the problem. It allows for trial and error and testing of new concepts, but it does have limitations. So if it is a highly sophisticated or complex project, or there's a lot of mathematical calculations, things like that, this is not going to be an appropriate approach. And by and large, it's mostly focused on what the user experience is going to be. So you're going to be working with end users to find out whether or not this has actually been successful. There are two types of prototypes that we look at. There are information gathering. So we use to gather information on the program itself, and this is then abandoned when testing is complete. And then there are evolutionary prototypes. What we are referring to here is that we've tested out some ideas, and if it's sort of working, then we actually may implement that prototype into a more structured approach later on with a more formalized development and everything else. So, features of the prototyping approach is that it's actually quite cheap because you're dealing with a small team, small time scale, not really an awful lot of money to spend on things. It's really mostly focused on testing ideas rather than actually trying to solve a problem as it is. Agile development, as I said before, is sort of like the current thing that people do. And it was developed in the early 2000s as a response to the way that development actually is usually done. And the term here is ad hoc. So, as what you decide to work on in a particular day is what you kind of feel like you should be working on at the start of the day. There is a very strong focus on teamwork. So you actually may even work in pairs or pair programming. That means that the two of you are working on the same program, one person typing, the other person offering moral support and or advice and or ideas and everything else. You'll tend to find that the projects are fairly small. So you'll be dealing with 4, 6, probably no more than 15 people working on a project. The budget itself, there isn't really a need for a budget in the same way with agile development, as you will come to see, because you are building a very quick to market application. So the time frame is going to be short because you're then going to use iteration later on to add features. So the idea is to get quickly to market so that you can actually see what's going to work and then implement changes as necessary. So, as I said, fast to get to market. It's really important to get out there and get something that users can use. After that, you use iterative releases to bring new features quickly so that you can respond to what's going on. You'll find that there are, particularly in the early days of the app stores, there was a lot of applications that changed direction rather rapidly as they discovered that they were actually they're answering the wrong problem, but they had the right data, or they had the right idea, but they weren't implementing it correctly. Probably one of the most interesting agile development projects was an application called Foursquare. You haven't heard of it because it doesn't exist in the same way anymore. Foursquare used to be a way of checking into locations and then becoming mayor. So it became a game. So when you went to your coffee shop, you'd check into the coffee shop, and if you checked into the coffee shop more than other people checked into the coffee shop, you became the mayor. You'd win points for checking into different places. And if the place didn't exist, you could add the place. And so all of a sudden they realized, hang on, we know everything about everywhere. We know about all the different coffee shops, we know about all the different pubs, all the different restaurants, all the different hotels. We know all of this location data. And so they pivoted. And now when you open up Google Maps, or if you open up Apple Maps, a lot of the data about the actual locations comes from Foursquare. Do they have an app that you can actually play the game with anymore? No, not really, because that's not what they were actually doing anymore. What they do now is sell that data to third parties because it's been entered in by everyone else. So these sorts of things, those sorts of stories are not unique. There are loads of different stories where an application has been developed and they've gone, you know what, this is kind of a different direction, and we'll go in that way and we'll adjust. And Agile allows you to do that because you have this iterative cycle of going through different releases. So you're very, very, I hate to say the word agile, but you're easily able to change in terms of market forces. So I've talked about Foursquare, but it's also particularly useful for websites. You'll find that a lot of mobile phone apps are created in this particular way. It's very useful if you have like an idea, but the end result's not clearly defined. So you can sort of move in a particular direction and try things out. Famous examples like Angry Birds was very agile. Minecraft was agile as a small team working in Sweden. Google Labs, which no longer really exists, was an example. Almost any indie app store application is going to be largely an agile development environment. And you find that agile teams exist within larger teams anyway as they build different sort of APIs and things like that. Rapid application development used to be the way that most things were built before sort of 2010, that sort of thing. And it's still fairly popular. Essentially, you focus on getting the job done quickly, but you're not going to solve the problem 100%. You're going to get close enough. And you're going to do this by using existing tools and libraries. So a lot of the code is already pre-made. You're largely just putting it in the right order so that it actually sort of solves the problem-ish. Very small team, a budget, small-scale projects. And you are limited by the number of languages that are actually suitable to this. So back in the day, before about 2005, you would use Visual Basic for a lot of these things because it integrates into with Microsoft Office and a lot of other things. C# can do this, Python can do this. You find that a lot of web applications are actually done in a RAD sort of way, using pre-existing sort of libraries like Bootstrap for all of the layout and everything else, and then you just write some code that makes that do something. The end user approach is the smallest. This is where it's actually done by the end user. So you're going to take something like Excel or Access, which is their database, or pre-existing web apps like Notion or Airtable or something like that, and actually then build something that solves a problem for you. So the typical and very cliched examples of this are restaurant manager keeping track of expenditure, or a tradie keeping tabs on costs, or a web developer wanting to keep track of his time to know which client to bill what. So very small, very little cost or time involved, although technically speaking, projects may never actually ever stop being developed. You might constantly be tinkering with your spreadsheet that keeps track of things, or constantly adding new features to your web app or whatever it happens to be. So it's very small, highly specific problems for one person, maybe two at most. So, summary of the 5 approaches. Structured. The advantages are that it's thoroughly tested, should meet the exact requirements, and uses a large range of experts, so you're going to get a good product at the end. However, it will be costly, time-consuming, and costly because of all of the different range of different skills, which might actually not be available to you all. Prototyping is relatively fast, models a larger project, allowing things to be seen and changed and all the rest of it. However, you may actually, at the end of the day, find it difficult to turn it into a fully working program. Agile will be fast, adaptive, responds quickly to market changes, allows you to get to market really quickly. However, you're likely to have a very bland application at first, so it won't have a lot of features. It may initially disappoint users. There might be a lot of hype about it, and then it doesn't deliver. And of course, you're never actually really quite done with it, so it requires continual development. Rapid application development is fast, cheap, uses mostly re-existing reusable code. However, it's not probably going to meet your exact requirements, and you do have to be careful about copyright and intellectual property. That can be a bit of a bugbear there. The end user, of course, should meet exact user requirements if you're able to create it. It's quick and cheap. However, you are limited by the products that you can use to do it, and you are limited within the boundaries of your abilities and everything else. Okay, so we have built the software. Now we have to implement it. So once we have a finished product, how are we going to get it into the user's hands? Is it going to be distributed, uploaded, or upgraded? This is a risky situation to find yourself in if you don't know what you're doing. Implementation will cost money. It will take up time, and it could potentially tie up many people going through the process. At risk is your reputation, your finances, the amount of time that it takes, and the productivity of the people that are using the software that you are implementing. You will need to choose which implementation strategy you take based on the size of the organization. If it's a large organization, it's going to change things if different to 3 or 4 people. If you are just upgrading your website, that's one thing. If it's a very complex program, you're going to have to be careful about how you go about it. Some organizations are actually easier to change things in than others. Some are fairly sort of traditional, stable workforces. Others have a younger, more vibrant, change-friendly attitude. So that will make them more flexible in what they actually want to do. And of course, when you are implementing something, you have to make sure that you're able to train the users in it. So in this course, we look at 4 common methods of implementation: the direct cutover, parallel, phased, and pilot. And they all have their own strengths and weaknesses. So let's start with parallel. As the name suggests, we run both systems at the same time for a period of time. Okay. Now this allows us to make sure that they both work. Well, the new one works. We have a backup in case something falls over. Users are able to sort of transfer to the new system, as they feel comfortable. However, you are running both bits of software, so it can be expensive. It will take a longer time because you'll find that a lot of people are sort of hesitant to use the new system. And you've got to be worried about what data is actually the source of truth. Are you mixing up the data? Is it just the new or is it the old? What are we doing here? When you're dealing with phase, this is probably better suited to large-scale, complex solutions. So you will gradually introduce new modules and features over time as they're being developed. So new modules can be tested and shown to work. Fantastic. However, you can end up with a situation where you've got very stressed out users because they've got mixed systems, data's getting mixed up, it's expensive at times, it can be very time consuming. You can end up with fatigue within the users as like every week there's a new change or new something that they have to get used to. So not always a good choice. With pilot, you're essentially choosing a small group within your business to actually test it out in isolation, so that if there are problems, it's only isolated to that small group. So let's say, for example, we've got a company that's nationally based. We've got offices in Sydney, Melbourne, Brisbane, and Adelaide. Well, we might decide that Adelaide gets the new system, and Adelaide can test it out and use it, and if there's any problems, they can report back to us before we implement it to our larger offices in Melbourne, Sydney, and elsewhere. So it's very good for making sure that it's going to work thoroughly. However, you're not always going to be in a position where you're actually able to do this, as you might not have a large enough group or a group that can be isolated. And what if the data is completely different? Now, I used to do this when I was a developer at the college, because I would have a software design class, And as I implemented new features for our student management system and learning management system that we were building back in the day, I'd get the year 12s to have special access to it so they could test it out, and then they could write error reports for me and things like that. And it was actually quite a bit of fun. So we had that sort of environment here where we could actually pilot test new features with a particular small class of students. You're not always going to have that luxury. And then we come to the direct cutover, the blunt object in the room, the brick wall across the motorway of implementation methods. This is where everyone goes home on a Friday afternoon. The director of IT orders 23 pizzas and 23 massive bottles of Coke, and the IT team sit the weekend and try to get the new system up and running. Monday morning, 8 o'clock, people come in and the new system is available. Fantastic, except there's no backup. You're just using the new software. Staff may have not read their emails on Friday and may not understand there's a new system on Monday. So they might be angry about that. And the poor IT staff, and I've done this, so I know, it is very stressful. If things start falling over, you're not getting any sleep, you know that you've got this very hard line due date. It has to be done. It is stressful. It can be a very difficult process to go through. So, summing up, when you come to choose an implementation, you need to understand that training the workforce is probably going to be one of the big issues. Not all staff groups are flexible. Not all staff groups are actually flexible enough to kind of take on change. You can find quite a bit of resistance. So training the staff and making them feel comfortable with the new software is going to cost money, and it's going to cause downtime because those staff are being taken out of their normal roles, sitting in training sessions, they're not being productive, they're not making money. You may run the cost of maintaining two systems. So the advantages may not actually be immediately apparent for a while. You will probably have to have a backup plan in place. That means that you're having to manage that as well. And if the system goes down for any reason, that's going to cost you money.